and welcome to Nkumat Online Academy. In today's chemistry class, we want to talk about valency. Valency is talking about the combining power of a chemical element or the number of electrons in the outermost shell of the atom. If we have an atom, the total number of electrons in its outermost shell is what we call the valency, and it is that number of electrons in the outermost shell that are involved during chemical reactions. And of course, you know that chemical reactions involves exchange of electrons. So, since it is only the electrons in the outermost shell that the atom can use during chemical reaction, it means that the valency or the atoms in the outermost shell is the combining power. That is the electrons that can use to combine with other atoms or other elements to form another substance or a compound. So, valency the combining power of an atom or element, or the total number of electrons in the outermost shell of an atom. Of course, you know that every atom may have many shells, and you already know that the first shell of an atom carries 2 electrons. Other shells, they carry 8 electrons. For instance, if you have an atom that has a total of 4 electrons or a total of 2 electrons, then to draw the shell of the atom, we are going to have, there's only 2 electrons, so we can just put, let's use this circular dot to represent electrons. So it has only 2, and this is the maximum that this first shell can carry. Then the next shell can carry a maximum of 8 electrons. So assuming that you have another atom that has 4 electrons. The first 2 electrons will go to the first shell. So this one is complete. Then the next electron, we still have 2 remaining. It will come to this shell. So we have the 2 here. If we have an atom that has 10 electrons, the first 2 electrons will go to the first shell, and the other ones will go to the second shell. So out of 10, we have taken 2, remaining 8. So we have the 8 here. Now, if you have another one that is 11, it is going to contain 3 shells. The first one will carry 2, the second shell will carry 8, this is complete. Now the third one will carry 2 plus 8 is 10, so remaining 1. We carry just 1. Now we have 2 and 8. Once an atom or the shell reaches 2 for the first shell and 8 for the other shells, we move to another shell. This is because it is only 2 in the first shell and 8 in the other shells that can make an atom to be stable. If an atom does not have up to 2 electrons in the first shell or 8 electrons in the other shells, the atom cannot be stable. So every atom is fighting to make sure that the first shell, that is the first shell that contains 2 electrons, and other shells that they have a complete of 8 electrons. If any atom does not have up to 8 electrons in the other shells, the atom will want to bond or combine with other atoms so that maybe it can share the one you have, or transfer some of the one you have, or borrow from another one to make the shells complete to 8 or 2, depending on the shells you are considering. And that forms the basis of chemical combination. Now today we are talking about valency. I said that the valency is the number of electrons in the outermost shell. Now that means that for this first one, the number of electrons in the outermost shell of this one is just 2. So 2 is the valency of this atom that has 2 electrons. Now for this atom that has 4 electrons, 2 also is the valency here. Although it contains 4 electrons, 2 is the valency because we have only 2 in the outermost shell. Now for this one, it has 10 electrons, but 8 is the valency here because we have 8 electrons in the outermost shell, in the last shell. So valency for here, valency equals to 2. For here, valency equal to 2 also. Now for this one, it has 11 electrons, but the valency is just 1. Why 1? Because we have only 1 electron in the outermost shell. So that is how to get the valency of an atom. If you are given any atom and you are asked to look for the valency of the atom, you have to draw the shells, put 2 electrons in the first shell, and the other shells will carry 8 electrons. If you don't want to draw it, you can also say, like the one that has 2, we have 2 electrons is equal to 2. We know that this 2 is the first shell. For the one that has 4, we can say it is the first one we carry 2. We write 2, we put comma, we separate it with comma. That is different shells. The first one carry 2, comma, then the other one has 2. So this one represents the first shell and this one represents the second shell, if you don't want to draw the structure. Then for the one that has 10, it is equal to 2. How many is remaining now? 8. So you put 8 in the second shell. Then for the one that has 11, it is equal to 2 in the first one. Now remaining 9, we have 8. The second one can carry only 8, maximum of 8 electrons. We put comma, we write the one remaining. So 1. So if you want to find the valency, you just look at the last shell here. The last shell here is just 2, so the 2 is the valency. The last shell here is 2, so 2 is the valency. The last shell here is 8, has 8 electrons, so 8 is the valency. The last shell here has 1, so 1 is the valency. So you can draw the structure to show it, or you can use this method to show it if you are not asked to draw the structure. So this is how to get the valency, and this last electrons here, like I've said before, is the combining power of the atom, or the electrons that are used during chemical reaction. So if this electron wants to combine with this atom wants to combine with another atom, it is going to take electrons from the ones in the outermost shell, from the valency, and that is why we call it the combining power of the atom. Now we use valency in getting the chemical formula of a compound. We can use valencies to get the chemical formula of a compound. How can we use valency to determine the chemical formula of a compound? Now let's assume that we have two atoms, A and B. Now let's say that the valency of A is 2 and the valency of B is 3. Now what this means is that the last electrons, that the number of electrons in the last shell of the atom A is 2, and the number of electrons in the last shell of atom B is 3. Now this does not tell us the total number of atoms that A contains and the total number of atoms that B contains. It's just telling us the number of electrons in the outermost shell, which is the valency. And that valency is all we need during chemical combination. So for us to determine the formula of a compound and we know the valency, we can use the valencies to get it. Now what we are going to do is this: during chemical combination or during chemical reactions, the atoms, they will exchange their valencies. So the valency of this A will come to B, and valency of B will come to A. The atoms in the last shell of A will go to B, and the atoms in the last shell of B will go to A. So we are now going to have A, it will now carry the 3, A 3, B 2. So this becomes the formula of this atom, assuming that of this compound, assuming that A and B are different elements. Example 2. If we have, let's consider the elements, these elements. We have D, 4, and we have F, 5. Assuming that these are different elements and we know their valencies. For us to combine this or to get a compound from this, we exchange their valencies. So the 5 here will go to this one and the 4 here will come to this one. So it becomes D, we carry 5. This 5 is written as subscript. A subscript is something that is written down on a value. Like if you write A, below it you write something like 2. That is subscript. So this 5 is actually written down. It's not in the same line with this D. So D5, F4. So the 4 here will be coming to F4. So this is the formula of this compound when D with valency of 4 and F with valency of 5 combine together. Now let's look at real chemical elements and see how they combine. Now assuming we have sodium and oxygen. We have sodium and oxygen and you want to combine them. Sodium is Na and oxygen is O. Now sodium has a total of 11 electrons. That is in the atom. So if it has a total of 11 electrons, just like I showed before how to get the valency, 11 is 2 in the first shell, remaining 9. The second one can carry maximum of 8 electrons, and then remaining 1. So we have 1. So in sodium, we have 1 as the valency. So 1 atom in the 1 electron in the last shell. So we have Na is 1. For oxygen, oxygen is Oxygen is 8. So we have 2 and then 6. You have 2 and we have 6. Now, for an atom that has more than 4 electrons in the atom's shell, the valency is the one it can borrow. That is the one that can complete the electrons in the atom's shell to 8. So the valency is either 6 or what can make this 6 to be 8? 2 electrons. 6 or 2. We normally use 2 as the valency of oxygen because it is easier for this atom, that is oxygen, to borrow 2 than for it to give out 6 electrons. Now the reason is because whether an atom is borrowing electron or giving out the one it has to spend energy. So it will spend more energy in giving out the 6 it has than in borrowing 2. So most of the times, oxygen will just borrow 2 electrons than giving out the 6 electrons it has. So that is why we normally take the 2 as the valency of oxygen. So the valency here is 2. That is the combining power. That is why we call it the combining power. The combining power is either the one the electron can give out, which is the number of electrons in the atom's shell, or the one it can gain or it can borrow, which is the one that can make the electrons in its atom's shell to be 8. So it is either giving out or it is gaining, and the essence of everything is to make the electron in the atom's shell to be either 2 or 8 depending on the shell you are considering. So for oxygen, for every atom that has more than 4 electrons in the atom's shell, it is easier for that one to borrow than for the atom to give out. So if an atom has 5 electrons in the atom's shell, it will be easier for the atom to borrow 3 to complete it to be 8 than for the atom to give out the 5. So in this case, we are going to be saying that the valency of the atom that has 5 electrons in its atom's shell, the valency is 3. For the one that has 7, it is easier for the atom to gain 1 electron and complete it to 8 than for it to give these 7 electrons. So the valency is going to be 1. So we are now going to be using 2 as the valency of oxygen here. So we have sodium 1 and we have oxygen 2. Now during this chemical combination, what will happen is that the valency of this oxygen will go to sodium and the valency of sodium will come to oxygen. So we have sodium will now carry 2, and then oxygen will carry 1. Oxygen is 1, but there's no need of writing the 1, so we just remove it. So it becomes Na2O. This is the formula of sodium oxide. In any textbook, in any chemistry textbook, if you are looking for the formula of sodium oxide, the formula is Na2O. Now, another example. If we have magnesium is Mg, that contains 2 electrons in the atom's shell. Now, your task, you are going to look for the atomic number of the first 20 elements and write out their shells and indicate their valency. So magnesium has 2 electrons in the, it's not 2 electrons, the valency is 2. It can borrow, the valency is 2, which means that it has 2 electrons in the outermost shell. Then, and we are combining it with oxygen. Oxygen has 2. Now, if magnesium is combining with oxygen, we are going to have these 2 here will go to this one, and the 2 here will come to this one. So we are going to have Mg2O2. Now what will happen is that if we have the same valencies here, 2 of them will cancel each other. So this cancel this. So the valency, the final chemical formula is MgO. So the formula of magnesium oxide is MgO. Now, one thing again is that we have all the elements are grouped into metals and non-metals. Metals are the ones that the number of atoms in their atom's shell is between 1 and 3. The non-metals are the ones that the number of electrons in the outermost shell is between 5 and 8. So these are non-metals. The ones that have 8, sometimes they can behave, they have 4 in the outermost shell. Sometimes they behave as metals, some others behave as non-metals. So they are special case. But the one that have between 1 and 4, 1 and 3, they are metals. The one that have between 5 and 8, they are non-metals. Then for the metals, they can give out their electrons during chemical reactions. And for non-metals, they can borrow electrons. So for those ones, for the non-metals, we consider their valency as the number of electrons they can borrow. If it is 5, it can borrow 3. If it is 6, it can borrow 2. And if it is 7, it can borrow 1. And 3, 2, and 1 can be the valency of non-metals. While for metals, 1, 2, and 3 can be the valency depending on what that one can give. So in this case, this one, magnesium is part of metal, oxygen is a non-metal. Now this combining of valency is mostly, we normally see it in when metal and non-metal are combining, which is what we call ionic bonding or ionic combination or electrovalent combination. Now let's look at other combinations. If we have tin is Sn and the valency is 4. And we have oxygen, the valency is 2. If they want to combine, we have this going to this and this coming to this. So we have Sn2 O4. Sn2 O4. Now something can cancel. 2 can go, we get 1. 2 go, we get 2. So we have the final one as SnO2. So the formula of tin oxide is SnO2. Now if we have copper and oxygen, the valency of copper is 2 and valency of oxygen is 2. They go. We have Cu2, oxygen 2. Again, this cancel. We have CuO. So the formula of copper oxide is CuO. Sodium and chlorine. We have sodium is 1 and chlorine is 1. Chlorine has 7 electrons in the outermost shell. So it is easier for it to borrow 1 and complete the electrons in the outermost shell to 8 than for it to lose the 7 electrons. So that is why the valency is 1. So we have 1. So when sodium and chlorine combine, it is going to give us sodium chloride, which is NaCl 1. So this is how to determine the chemical formula of a compound using their valencies or the valencies of the combining atoms. Now, your assignment. Now you are going to determine the formula of a compound that is formed when we have when these atoms combine. Number 1, an atom A, it has valency of 5, and atom B, it has valency of 6. So we determine the chemical formula of the compound that is formed when these two atoms combine. Number 2, you determine the chemical formula when this atom combines. When these atoms combine, we have when potassium and oxygen combine, get the chemical formula. Of course, I've shown you. The first thing you do is for you to get the valency of each of them, and then from the valency, then you combine. Then, when we have when we have magnesium and chlorine, when magnesium and chlorine combine, you get the chemical formula. When sodium when sodium is combined with when sodium is combined with fluorine, get the chemical formula. Then when tin is combined with when tin is combined with chlorine, get the formula. So these are the tasks you have. Number one, find the chemical formula when A with valency of 5 and B with valency of 6. And then B, magnesium and chlorine, sodium and fluorine, tin and chlorine. Then next one, when we have A, this A has a total of 8 electrons. Is combining with, when A combines with another element B, and B contains a total of 15 electrons. You find the chemical formula of the compound formed. Now this one is different from the first question, number 1. This one, the total number of electrons is 8, and the total number of electrons in the atom is 15 here. But in first question, the valency, I didn't tell you the total number of electrons, I just told you straight the valency. Here 5 is the valency, that is why I wrote it under A, and B 6 is the valency, I wrote it under. It's not a subscript, it is written under it to show that this is the valency of it. So you are going to use 6 straight as the valency of B and 5 straight as the valency of A. Now, but in this one, in number 6, A contains a total number of 8 electrons and B contains a total number of 15 electrons. So you are now going to determine the valency of A and B using the total number of electrons that they have. Okay, so this is the assignment. Now, before I end the lesson, let me say it again, that this combining of A or valencies is possible in ionic bonding. That is when a metal and non-metal are combining. If you are given 2 non-metals or 2 metals to combine, you don't use this method to show the combination. We are going to learn other chemical combination in our next lesson, but this one is for combination that involves metal and non-metal. So in your question or in your exam, you may see a question that maybe in OBJ they will give you different elements and ask you which of these is possible, which of these, the following combination is possible. They will give you 2 metals and give you 2 non-metals and give you a metal and non-metal. If they ask which of them is possible, you cannot choose 2 metals and you cannot choose 2 non-metals. The only one that is possible is when it involves a metal and non-metal. That is only when you can use the exchange of valencies to determine the chemical formula. Using exchange of formulas, exchange of valency is possible only when we have metal and non-metal. Okay, with that, I've come to the end of this lesson. Thank you.